I've taken this picture from the last video to use as a visual aid. When we wrote down the definition of the derivative, we used this h term, which we think of as the distance from a to our limiting point on the right. We then took a limit as the distance went to 0. Our usual difference quotient is then the slope of the secant line, f of a plus h minus f of a divided by h. But instead of thinking about things in terms of their distance, why not just give the limiting point a new name, say z? So let's go around this picture and change everything with an h into a corresponding statement about our new point z. Look at what the slope of the secant line would now be. We can write this in terms of z as f of z minus f of a divided by z minus a. The only thing left is to sort out what the limit becomes. If we write z equals a plus h, then as h goes to 0, we see that z goes to a. Thus, our usual definition of the derivative, written like so, can instead be written in terms of z. I'll do an example using both definitions of the limit to show you that they give the exact same answer. If f of x equals x cubed, let's then find the derivative at the point 2. First up, we'll use the old way. If you need more practice, now would be a good time to stop the video and make sure you can do this computation on your own. We're going to expand out the 2 plus h cubed term and do as much canceling as possible. The result is this continuous function, from which we see that subbing in h equals 0 gives us the answer 12. The new way is going to give us exactly the same answer, but the computation is going to be very, very different. Okay, again, now would be a good time to pause the video and see if you can work it out for yourself first. Unlike the old way, where we expanded a product, this time we'll need to factor a difference of cubes. Hopefully you remember how to do that, and if so, you see that there's this nice cancellation of the z minus 2 terms. The leftover function ends up being continuous in z. So we plug in z equals 2 to get our expected answer of 12. Now there are times when one of these definitions is easier than the other, but sometimes they're roughly the same difficulty. In any case, it's good to have a second tool in our toolbox for attacking derivatives.